What is up, everybody? Welcome back to the Maths Guy. My name is Matt, and today we're going to be doing something pretty exciting. We're going to go back in time and look at the 2022 Test 1 maths paper, which is the arithmetic paper. Now, what I would recommend at this point is to download and print the test yourself. I'll put a link in the description below. Give yourself no more than 30 minutes to try and do as many of the questions as possible, and then come back and we'll work through the questions together. You'll see how many you got right, and you'll see which ones you have to have a little bit of a practice at. But if you don't want to do that, you can just follow with me and we're going to have a little go at doing them all together. So let's not waste any time, let's jump into it. Okay, now the first thing to say is that a lot of these questions are going to have multiple different ways of solving them. You only have half an hour to do this test, so you really want to try and find the quickest and most efficient way of solving these questions. So with that in mind, if we have a look at question 1, we can see that this is an addition question. We could set up our column addition, or we could try and help ourselves a little bit and notice that we have 501 and 649. So if I use the 1 from here and add it over to my 649, I effectively have 500 plus 650. 500 and 650 is obviously 1150, which is much easier to then add on to my 6155, and now I can do my column addition a lot easier. So that'd be 5, my tens column would be 5 add 5, which is 10, my hundreds would be 1, 2 and 3, and in my thousands I've got a 1 and a 6 equals 7. So my answer for question 1, 7,305. Okay, question 2, this is a great one. 0 times 989. This is going to be no working out because anything multiplied by a 0 is going to equal 0. They're trying to trick you here. Some people will put 989 as the answer, but we should know that anything multiplied by a 0 is going to give us an answer of 0. Okay, question 3. This is an inverse question. We have 10 plus something equals 302. So we could inverse this and do 302 subtract 10 equals 292. And if we wanted to check this, we could put 10 plus 292, and then we can see that that equals 302. So my answer is 292. Okay, question 4. This says 2,400 divided by 2. Now anything that's divided by 2 effectively just means to halve it, so we're going to try and halve 2,400. Some of you will be able to see that half of 2,400 is 1,200, but if we wanted to check it, we could do our bus stop 2,400 and put our 2 outside, and we can work out how many 2's are in 2, 1, how many 2's are in 4, 2, how many 2's are in 0, 0, and 0, 0. Same answer, so our answer is 1,200. Okay, for this next one we have another inverse question. This says something plus 70 equals 485, so therefore 485 subtract my 70 is going to give us our answer. So I'm going to do a quick column subtraction. 485 subtract 70, 5 subtract 0 is 5, 8 subtract 7 is 1, 4 subtract nothing is 4. So my answer is 415. Okay, question 6. 6.48 plus 8.6. There's no super quick way to work this out, so we're going to just set up our column method. 6.48, and then what they're trying to do is trick you because they've got a different amount of decimals on this second number of only 8.6. So if you want to, you could put your titles above your numbers. This would be my ones, my decimal, my tenths, and my hundredths. And now in my 8.6 I can see I've got 8 ones, my decimal, and my 6 tens, and therefore I have this gap that I can fill with a placeholder, a 0. Now I'm just going to simply add them up. 8 add 0 is 8, 4 add 6 is 10, put back my decimal, that's really important. 6 add 8 is 14, plus the 1 is 15. So my answer is 15.08. Okay, question 7. This is another funny little one because they're trying to trick you by putting this equal sign seemingly at the start of our question. But remember, it doesn't matter which way around we put our equal sign, everything on either end will be equal. So this question is basically asking us what 240 divided by 8 is. So a couple of ways I can do it. I could look at just 24 and say how many 8s are there in 24? There are 3, but 24 is 10 times smaller than 240, so I must now make my 3 10 times larger by putting a 0 after it. Or again, I could set up a quick bus stop, 240 and 8. How many 8s are in 2? 0, roll the 2 across. How many 8s are there in 24? 3. How many 8s in 0? 0. So I get the same answer, so my answer is 30. 30 equals 240 divided by 8. Question 8 says 840 divided by 5. So what I could do is 840 divided by 10. In my head I know that's 84, but we're dividing it by 5, so I need to double my 84 because 10 is double 5. So 84 plus 84 is 168. Or again, it's a division question, so I could use my bus stop. Same answer, 168. Okay, question 9. Again, no super quick way of working this out. We're going to have to use some column subtraction. And I've got 7,306 subtract 1,847. For the sake of time, I'm not going to bother putting my titles above these numbers because we have 4 digits in one and 4 digits in the other. So 6 subtract 7, I can't do. Now a lot of people here would write 1 as our answer, but hopefully we know that 1 is not the correct answer, because if I have 6, 1, 2, 3, 4, 5, 6, I cannot take 7 away. There's only 6 there. I can't just flip the question around and say 7 subtract 6, that doesn't work. So I have to look next door, but there's nothing next door, so I'm going to look next door again, and I'm going to take that 3 down to a 2 and borrow the whole group over to my 10s column. Now my 6 can look next door again at the 10, take it down to a 9 and borrow a whole group of 10. Now I'm ready to start with 16 subtract 7. 16 subtract 7 is 9. 9 subtract 4 is 5. 2 subtract 8 I can't do, so I'm going to look next door again, take this 7 down to a 6 and put a 1 in front of my 2. 12 subtract 8 is 4. 6 subtract 1 is 5. So my answer is 5,459. Okay, this is a nice one. 1,010 multiplied by 10. What we can do here is use our place value chart. Quickly draw a place value chart. I've got no decimals, so I'm going to start with ones, tens, hundreds, thousands. I'm going to put a 10,000s in there for good measure, and then simply put in my number, 1,010. So 1,010 has 0 ones, 110, 0 hundreds, and 1 1,000. And then hopefully we understand how to use a place value chart. If we're multiplying by 10, we can just simply move all the digits one place to the left, because that's going to get them 10 times larger. So we can move our 1 into our 10,000s, our 0 into our thousands, my 1 into the hundreds column, my 0 into the tens, but then it's going to leave me with this gap that I'm going to have to fill with a placeholder. So my answer is 10,100. Okay, question 11, 560 divided by 7. Well, again, we can see that this has this little 0 here, so we could just do 56 divided by 7, which equals 8. And then because 56 is 10 times smaller than 560, we could make 8 10 times larger by multiplying it by 10, equaling 80. So my answer is 80. Or if I wanted to, I could just do the bus stop again. Okay, question 12. Question 12 is a multiplication, but it's actually multiplying 3 digits. And what we should know about multiplication is it's commutative, which means that we can put these numbers in any order and we're going to still get the same answer. So it makes sense to work it out in an order that's going to be easiest. I would say it's in that order already, because we could do 6 times 10 equaling 60, and then 60 times 11 is 660. So my answer is 660. Question 13 is again one looking for you to notice that we have this 0, so we can use place value knowledge to work this out. And I can just look at this 108 and say 108 divided by 9. And if we're good at our multiplications, we can see that equals 12. And then again, times 10 is 120. I could quickly check this in my bus stop. So my answer is 120. Okay, 14. This is another sort of place value one, because really what we can see is 500,000 subtract 5,000. The way that I would look at this is looking at these numbers after the comma. We should know that these are all the thousands. So I could just focus on that for now and say 500 subtract 5 is 495, and then put back my 3 zeros. So my answer is 495,000. Question 15, there's no real trick to this, it's just a multiplication question. 596 times 7, so we're just going to work it out in columns. So 596 times 7, and I'm ready to start. Where do I start? I start at my smallest value. 7 times 6 is 42. Then I do 7 times 9, 7 nines are 63, plus my 4, 67. Then 7 times 5, 7 times 5 is 35, plus my 6, 41. So my answer is 4,172. Okay, question 16. This is another place value question. Any question that's multiplying or dividing by 10, 100, 1,000, etc. is just going to be using our place value chart. So I'm going to build my place value chart first of all. And because we've got decimals and I'm dividing, I'm actually only going to put my ones here because I know I'm not going to need any more than that. Put my decimal in place, tenths, 100ths and 1,000ths. And now put my number in place. I've got 2.12. And now when dividing, I'm going to be moving them down the place value chart. So this 2 in the hundreds column comes into the thousandths. The 1 goes into the hundredths. The 2 goes into the tenths. And I've got nothing in front of the decimal, so I could just put a 0. So my answer is 0.212. Okay, question 17, and this is going to be the first one that's worth 2 marks, you can see down here. And it says show your method. So it wants you to show clearly how you've worked this question out so that you get both of the marks. So this is a division question where we're dividing by a 2-digit number. So for me, it makes sense to write a little multiplication table of this 2-digit number so that we can use it to help us with the division. So I'm going to put 21, 2 21s are 42, then it'd be 63, 84, and I'm going to do one more, which is 105. Now I can use that to help me in a moment. So how many 21s are in 6? Well, there's 0, and I'm going to put my 6 next to the 7. How many 21s in 67? Well, I've got 1, 2, 3, with 4 left over. Put that next to the 2. Finally, how many 21s in 42? Well, I can see 1, 2. So my answer is 32. And I've clearly showed my workings out, so I should get both marks. Question 18, our first fraction question. And this fraction question says 4/9 plus 2/3. Well, we know that we can't add fractions unless we have the same denominators. So I'm looking to try and find an equivalent fraction of one of these, if not both, to make sure that I have the same denominators. Well, I can already see that this 3 and 9 have a relationship because 3 3s are 9. So I can actually then think about that to help me with my equivalent fraction. So I'm going to put back my 4 over 9 and we're adding it to 2/3. But I'm going to turn this 2/3 into an equivalent fraction. So I'm going to try and get my 3 to a 9. And how did I do that? I multiplied by 3. So if I multiply the denominator by 3, I then must multiply the numerator by 3. 4 times 3 is 6. So 2/3 is equivalent to 6/9. So now I'm just adding 4/9 plus 6/9. And I should know that I'm going to be getting an answer that's going to be in 9ths. And I just need to add the numerators. 4 plus 6 is 10. My answer is 10/9. Now this fraction is an improper fraction. To get the mark, that's absolutely fine, but if you really wanted to show off, we could turn it into a mixed number by realizing that this is actually 1 and 1/9. Either of these is fine. Question 19 is another multiplication question, and again, no tricks to it. We're just being asked to multiply, and it's already set it out ready for us, but again, you can see it wants us to clearly show our method. Okay, so really this line here is going to be answering 3 times 607, and this next line is going to be answering 80 times 607. And I do mean 80 because don't forget this 8 is in the tens column, so it represents an 80. Okay, start with my smallest values, and 3 times 7 is 21. 3 times 0 is 0, plus my 2 gives me a 2. 3 times 6 is 18. Now what I like to make sure I do at this point is clearly cross out this 2 here that I used so that I don't add it to my calculations in a moment. Now I move on to my second line, but I must make sure that I'm making it 10 times larger if I want to just multiply by the 8, so I'm going to put my placeholder. This is what people make a mistake with. They will forget that placeholder and therefore the whole question will be wrong. Remember, this 8 is in the tens column, so if we want to only treat it as an 8, we have to make the answer 10 times larger, so we put the placeholder. Okay, now I can do 8 times 7. 8 times 7 is 56. 8 times 0 is 0 plus the 5, and then 8 times 6 is 48. Make sure I cross out that 5. Now I'm ready to add up, because at the moment I've just done the individual small parts. Now I need to get a total. So 1, so starting in my ones column, 1 add 0 is 1, 2 add 6 is 8, 8 and 5 is 13, 1 add 8 plus my 1 is 10, 4 add the 1 is 5. So my answer is 50,381. And again, I'll get the 2 marks. Question 20 is another place value one, because look, we're timesing by 1,000. So I can just set my place value chart up again. But I can see I've got 100ths and tenths. So I'm going to put hundredths here, tenths, put my decimal, and then ones, tens, hundreds, thousands, 10,000s. And then I'm going to put my number in place. So it's 1 in the tens column, 3 in the ones column, my decimal, 0 in the tenths column, 5 in the hundredths column. And I'm moving them 1, 2, 3 times when we're timesing by 1,000. So here we go, 1, 2, 3. My 1 moves into the 10,000. My 3 goes into the 1, 2, 3, my thousands column. The 0 goes into the 1, 2, 3 hundreds column. And my 5 into the 1, 2, 3 tens column. But I have this little gap that I must fill with a placeholder. So my answer is 13,050. We have 2 thirds added to 2 and 1 third. So what we actually have here is a mixed number, and we don't really want to add with our mixed number, so we're going to convert this into a fraction. And what we can see is the associated denominator value is in thirds. So to get a whole we would need 3 thirds. So to get 2 wholes we would need 6 thirds. So this 6 thirds is equivalent to our 2. So now what we're going to do is add our original 2 thirds plus our new 6 thirds plus the 1 third. So our answer is going to be in thirds. We have 2 plus 6, which is 8, plus 1, which is 9. So our answer is 9 thirds. And again, even though it's an improper fraction, we don't need to convert it. That is absolutely fine. Question 22. Now we're looking at a fraction of an amount, and the amount is 30. And we're looking for 7/10 of this 30. So what we need to do first is find out what 1/10 is by dividing it by 10. So 30 divided by 10 equals 3. But we weren't looking for just 1/10, we wanted 7/10. So now we'd get 3 multiplied by our 7 equals 21. So my answer is 21. A good tip is to just make sure your answer is smaller than the number that you started with, because remember, if we're trying to find a fraction of this amount, the number will always be smaller than our answer. Question 23 is a subtraction question, and again, no tricks for this, we just need to lay it out correctly. So I have 8 subtract 5.123. Now, a mistake that people could make is putting this 8 over here above the 3, just because they're trying to line it up on the right hand side, which is what's kind of common. What we want to think about is the value of the digits, and the 8 and the 5 are both ones. Then we have our decimal, tenths, 100ths and 1,000ths. And by putting these little labels above, it helps us to just make sure we're putting things into the correct space. But we do have these 3 blank gaps, and we need to fill them with something, so we're going to use placeholders. So I'm going to put some zeros in here. Now I can begin, and this question is a little bit tricky because I have my first question saying 0 subtract 3, and I can't do it, and I can't look next door, and I can't even look next door beyond that. But this 0 can look next door, so he'll knock that down to a 7, and that'll become a 10. I'll start again with my first 0. 0 subtract 3, cannot do. So I'll look next door, can't do, look next door again, can do. So then this 10 becomes a 9, and I have a 10 in my hundredths column. Now I'll start again, 0 subtract 3, still can't do it, but at this point I can look next door, take this down to a 9, a little bit messy, really helps be super organized here and just be very conscious of what you're doing. 10 subtract 3 is 7, then I have the 9 subtract 2, which is also 7, 9 subtract 1, which is 8, put back my decimal, very important, and then 7 subtract 5, which is 2. So my answer is 2.877. Don't forget to put your decimal point. That is what people will forget sometimes, and it's a silly point to give away. Okay, question 24 is a fraction divided by a whole number, and there's actually a trick to this. So what we can do is put our fraction, 1/8, and then we're going to divide it by our whole number, which is 2, but we're going to turn 2 into a fraction by just putting it over 1. That maintains its value, still has the value of being 2, but it's now in fraction form. And what I can do now is just do the butterfly trick, which is to multiply rather than divide the numerator of the first fraction by the denominator of the second, and this will give us the numerator of our answer. So 1 times 1 is 1, and then this is why it's called the butterfly. You can see now I get the denominator and the numerator of the other one. 8 times 2 is 16, and that's our answer, 1/16. Okay, 25 is another fraction, but this time we're using addition. But what we can see is we do not have like denominators, and there's no relationship directly between these 2 and 3. So we're going to have to find new denominators and equivalent fractions for both. So let's put these in the middle, and then we're going to try and find a common denominator. And the easiest way to do that is just get our denominator from both and multiply them together. 2 times 3 is 6. And I now know that 6 is going to be a multiple of both of these because we used each of them to multiply. So now I can ask myself, how did I get from 3 to 6? Well, I had to times it by 2, so I now need to do that to the numerator, times it by 2. 1 times 2 is 2. Then on the other side, how did I get from 2 to 6? I times by 3, so I must do the same to my numerator, and 1 times 3 is 3. So my new equivalent fractions are 3/6 and 2/6. And all I'm going to do is add my numerators. 3 add 2 is 5, and the values were 6. So my answer is 5/6. Okay, question 26, another subtraction. And again, no trick for this. We're just going to have to work it out using column subtraction. I'm going to put my 1s and 10s labels ready so that I don't make a mistake. And then I'm simply going to put my 26, 2 10s, 6 1s, subtract 2.012. That has 2 1s, and then I can fill the rest in beyond that, 0.012. Put my placeholders, and I'm ready to start. And again, it's one of these where I'm going to be borrowing a lot from next door. So 0 subtract 2 I can't do, can't look next door, can't look next door again, but this 0 can look next door and knock the 6 down to a 5, giving him a 1. Again, can't look next door, but this 0 can, so he'll knock that down to a 9 and a 1. Now I can look next door for the first one, knock it down to a 9 and move the 1 across. Now I can actually start. 10 subtract 2 is 8, 9 subtract 1 is 8, 9 subtract 0 is 9, put back the decimal, make sure we always do that, and then it's 5 subtract 2, which is 3, and then 2 subtract 0, which is 2. So my answer is 23.988. Okay, 15% of 3,200. Easiest way to do this is just find 10%, and 10% would be 320. But I wasn't looking for 10%, I need 15, so I'm going to find another 5%, which will then be half of that. Half of 320 is 160, and then simply add those two together because that will give me the 15, give me 0, 8, 4, so my answer is 480. Easy. Okay, 28, 2% of 3,000. Well, easiest way would be to find 1%, and 1% would be dividing by 100, so I could get my place value chart up and physically divide it by 100. Dividing it by 100 will move them all 2 places, so 1, 2, my 3 will be in the 10s column, and I'll have a 0 in the 1s column. So I know that 1% equals 30, so therefore 2% equals 60. Question 29, we've got another show your method. So we're looking for 2 marks, and again we're dividing by a 2-digit number, so it makes sense to start with our multiplications of that 2 digits, and I've got 73. 146. And sometimes it can be quite hard to find the next multiple, so you can just simply do an addition question if you wanted to. 146, add 73, 6 and 3 is 9, 4 and 7 is 11, 1 and 1 is 2, so I'd have 219, and I know the next one is 292, and the next one after that 365. Okay, I'm going to leave it at 5 for now, hopefully we won't need any more. So let's begin. 73's into 3 will go 0, put the 3 across, 73 into 30, again 0, put the 30 across, and 73 into 306, well I can go 1, 2, 3, 4, can't go further than that, so I've got 4, and then how many did I have left over? Well, I was looking for 306, and I got to 292, so I can see the difference between the two is 14. So a remainder of 14, and then 73's into 146 goes exactly once and twice, leaving my answer of 42. Okay, question 30. 80% of 115. Well, with any percentages, it's easier to just work out 10%, so let's do 10% of 115 will equal 11.5. If you can't see that in your head, just do your place value chart, and then we're going to multiply it by 8. So first I'll multiply 11 times 8, which is 88, and then 0.5 times 8, which equals 4. Add the two together, 92. Giving me an answer of 92. Okay, we're getting towards the end now. Question 31, 2/7 minus 1/9. And again, unlike denominators, so we're going to need to find equivalent fractions. So let's put it in the middle, 2/7 minus 1/9. Remember, the trick for finding those common denominators is to just get a multiple of the two of them, and we can always do that by multiplying them together. 7 times 9 is 63. So then how did I get from 9 to 63? I had to multiply by 7. So I'll do that to the numerator 2. 1 times 7 is 7. And then how did I get from 7 to 63? I times it by 9. So I'll have to do that to the 2 as well. 2 times 9 is 18. So now I have 18 63's, subtract 7 63's, which is 11 63's. And again, don't worry about simplifying or anything like that. Even if it's possible, just get the answer. Question 32, we have another mixed number. So remember, we're going to have to change this mixed number into a fraction, or specifically the whole number. So looking at my fraction, it's in halves or twos. How many halves make a whole? 2. So how many halves make 2 wholes? 4. So we've got 4 halves representing my 2. Added to my 1/2 gives me 5 halves. So this mixed number, 2 and 1/2, is equivalent to 5 halves. And now I can just do 5 halves, subtract 2/3, and I can see again I'm going to need to find some common denominators because 2 and 3 are different, and a common denominator of both would be 6. I'll do them over here this time. So to get from 2 to 6, I times by 3, so I'll do that to my 5, which is 15, and to get from 3 to 6, I times by 2, so I'll do that to my 2, which is 4. Now I can do the actual question. 15/6 subtract 4/6 equals 11/6. And again, remember 11/6 is okay, but the mixed number would have been 1 and 5/6. Okay, 33, a multiplication, and they always like to put a load of 8s and 7s in these multiplications just to try and catch you out, because they are probably the hardest multiplications. So just take your time. If you want to write out a list of the multiples, that might help. But again, remember, this first line is essentially 7 multiplied by 4078, and the second line is 60 multiplied by 4078. Remember, the 60 is because this is in the tens column. 7 times 8 is 56. Put my small 5, big 6. 7 7s are 49, plus my 5, 54. 7 times 0 is 0, plus my 5 gives me 5. And then 7 times 4 is 28. Get rid of the small numbers because we've used them. And now I can do 60 times 4078 and show that it's 10 times larger than just the 6 we're going to work with by putting the 0 in. Now 6 times 8 is 48. 6 times 7 is 42, plus my 4, so 46. And then 6 times 0 would be 0, plus my 4 leaves me with 4. 6 times 4 is 24. Get rid of the little numbers again, and now I can just add it up. So in my 1's column, 6 and 0 is 6, 4 and 8 is 12, 5 and 6 is 11, plus the 1, 12, 8 and 4 is 12, plus the 1, 13, 2 and 4 is 6, plus the 1 is 7, 2 on its own is 2. So we have an answer of 273,226. Now if you're confident with your multiplication, the only way that you're going to drop points there is with your untidiness or presentation. So it's really important to try and be as big and as clear as possible when doing this kind of problem. Use the whole space in here if you want to, so you don't make any small mistakes. Okay, 34, we're on the last page, and we have 10 subtract 2 and 1/4. So we have a whole number subtract a mixed number. And this actually isn't as hard as it looks, because what we can do is we can just do 10 subtract 2, which equals 8. And another way of saying 8 would be 7 and 4/4. And then if we're taking one of those quarters away, we're going to be left with 7 and 3/4. And that's my answer, 7 and 3/4. 35. This is a BODMAS question. If you don't know what BODMAS is, check out the video that I'll link above. But it's basically saying, do you understand the order of operations that we are supposed to work a question out in? And according to BODMAS, if I write it here, we have brackets, order, division, multiplication, addition, and subtraction. And as we can see, division is in front of our addition. So in this question, we're going to have to do our division first. So what I like to do is write it out step by step. So it's 6 plus 4 divided by 2. The first step is to do the 4 divided by 2, so I'd get 6 plus 2, because 4 divided by 2 is 2. And then on my last row, 6 plus 2 equals 8. And finally, last question, 4/5 times by 400. And again, this is one of those ones where they're trying to make it look really complicated, but actually it's kind of easy, because what they're saying by multiplication is essentially of. So we're looking at 4/5 of 400, which all of a sudden looks a lot easier, because I can just do 400 divided by 5 to get what 1/5 is. And again, I could use my bus stop to work that out. 4's into 5, don't go. 4's into 40, go 8 times. 4's into 0, go 0. So my answer is 80. But it wasn't just looking for 1/5, I want 4/5. So 80 times 4 equals 320. There is another way we could work this out. What I could do is 4/5 multiplied by 400, which, remember, as a fraction would be just 400 over 1. So if I'm multiplying fractions, all I have to do is go along the rows. So 4 times 400 would be 1600, and then 5 times 1 is 5. And again, you could leave this as an improper fraction, but if you didn't want to, you could work out how many 5 wholes were in the 1600 by doing 1600 divided by 5. Same answer, 320. And there we have it. That is the end of the test. So if you did go through this first and get your own answers, you'll have a score for yourself now. Focus on the ones that you didn't get right. Go back and watch them on the video and see how, again, we did that before having a second attempt. But hopefully this has been really useful for you. I know how important it is to go through these exams and be confident with them before taking on one for yourself. So hopefully this has been helpful. If it has, think about subscribing to the channel. We have daily maths videos coming out to help you. But for now, peace out. Okay, so question 1 says circle the greatest number. Greatest obviously means the largest number, the number with the highest value. So this is a place value question, and because we're looking for the greatest, we're going to look in the greatest value column, which will be this million column to start with. And we can see that we have 9 million in all of them, so that column's not going to help us. Then we can look in the hundred thousands column, and we can see we have 2, 2, 2, 2, and another 2. So again, that column doesn't help us. Then we can look in our tens of thousands column. Well, in this one we have a 0, but in this one we have 1, 0, 1 and 0. So we can get rid of the zeros because they obviously can't be the greatest value. And now I'm looking between these two here. I'll look in my thousands column, but I have a 5 in one and a 5 in the other, so that doesn't help me. Then I can look in my hundreds column. Well, I have a 3 in this one and only a 2 in this one. So therefore, this number is my greatest. Now it's important we follow the instructions. It says circle, so we're going to circle. Question 2 says, one table can seat 8 people. How many tables are needed to seat 40 people? So we have a couple of options. We could either go up in our 8 times table. So this would be 1 table. This would be 2 tables. 24 would be 3 tables. 32 would be 4. 40 would be 5. So 40 people would be 5 tables. Or I could do it another way. I could do 40 divided by my 8. 8s into 4s don't go. Roll it across. 8s into 40 go 5 times. Same answer. Question 3 says, write the missing number to make the addition correct. So really what we're doing is we're trying to find some patterns. And I can see here that we have partitioning because look, if we see our answer, we have 430,070. Well, I have my 400,000 over here, this value. I have my 70 over here. So the only thing I'm missing is this 30,000. So I'm going to put 30,000. We could check it by partitioning the number ourselves. So 430,070 could be partitioned into a 400,000, a 30,000, and a 70. We have the 400,000, we have the 30,000, we have the 70. Give ourselves a mark. Question 4 says, children estimate the number of beans in a jar. These were the estimates of 5 children. We can see in this table we have those estimates. Then it says the exact number of the beans was 1,380. And then we have 2 questions. First one says, whose was the closest to the exact number? And then the second question says, whose estimate was furthest from the exact number? So if the correct answer was 1,380, we've got a little bit of legwork to do. We're going to work out the difference between this 1,380 and each of their guesses. So what's the difference between Amir's guess, 1,310 to 1,380? Well, that's a difference of 70. Olivia guessed 1,220, quite a long way away, Olivia. That's 160 away. I'm just doing it in my head, but if you wanted to work it out, you could simply do some column additional subtraction in the space around. Emma guessed 1,400. Wow, Emma, that's only 20 away. And then John, 1,290. So he's 90 away. And then Chen was 80 away. Okay, so whose estimate was the closest? Well, we can clearly see that good old Emma got it only 20 away. But I cannot just write 20 because what's it asking me? Again, we've got to be super careful with this. It says whose. So it wants me to write Emma. Don't throw easy marks away. Make sure you read the question perfectly. Then it says whose estimate was furthest from the exact one. Well, I don't know. Olivia's had a bit of a stinker. She guessed 160, so it's going to be Olivia. Sorry, Olivia. 2 marks. Question 5 says 1 ton is 1,000 kilograms. So they've actually given us the conversion here. A truck can carry a load of 2.3 tons. How many kilograms can the truck carry? Okay, so we can use some place value knowledge and draw out a place value chart, or we can just do 2.3 times 1,000 in our heads, which is going to be 2,300. If you want to see what it would look like in a place value chart, let's do it. My original number was 2.3, and then to times it by 1,000, I need to move them 1, 2, 3 places, and then I've got these gaps that I need to now fill with placeholders, and I get the same answer, 2,300. And they've even been very kind and put our kilograms, because if they hadn't and we didn't put it, we might get the answer wrong. Question 6, Emma again. Emma has a 5-litre bag of compost. What is she doing with that? She uses 2.75 litres. How much compost does Emma have left? Well, again, we can be quick and use our heads if we've got good mental arithmetic. So we're just doing 5, which is essentially 5.00, and we're subtracting 2.75. Well, I can see that 5 subtract 2.75 would give me an answer of 2.25. But let's check it. 0 subtract 5 I can't do. I can't borrow next door, but he can borrow from next door. Get him down to a 4. And then this is now 10. Let's start again. 0 subtract 5 can't do, but I can now borrow from next door. Put that down to a 9. And now that's a 10. 10 subtract 5 is 5. 9 subtract 7 is 2. Put my decimal back. 4 subtract 2 is 2. 2.25. 2.25 litres. Question 7 says, in a race, Ali completes a swim, a run and a bicycle ride. Pretty active weekend for Ali. The swim is 1/10 of the total distance and the run is 3/10 of the total distance. What fraction of the total distance is the bicycle ride? Okay, so we've not been told the bicycle ride, but we know the swim is 1/10 and we know the run is 3/10. So the whole race, we should understand, is 10/10 or a whole. If we subtract the swim, that would leave us with 10/10 subtract 1/10, which is 9/10. And now if we subtract the run from that 9/10, we would have 9/10 subtract 3/10, which equals 6/10. So the bicycle ride was 6/10 of the whole journey. Circle the improper fraction that is equivalent to 2 3/8. So what is an improper fraction? An improper fraction is a fraction which has a larger numerator, the number on the top, than the denominator. So this is an improper, this is improper, this is improper, and this is improper, but this is actually not improper. So we've got our 2 3/8. Let's put it down here. And we're going to try and turn it into an improper fraction. Okay, so what we need to do to try and find the fraction of these 2's, these 2 wholes, is we're going to look at how many 8ths are in one whole. Our fraction is out of 8, so we need to work out how many 8ths are in one whole. And 8/8 would make one whole. But we've got 2 wholes, so therefore 16/8 would make 2 wholes. But don't forget that we've got this other 3 as well. So my 16 plus the 3 would give me 19/8 as an improper fraction. Do we have that in one of our options? Yep, there it is. There's our answer. And again, it says to circle, so we must circle. Question 9, and this is a classic one that people will make mistakes on. So let's have a look at it. It says this pictogram shows how many DVDs a shop sells in 1 week. So let's just understand that this DVD here is not a value of 1 DVD. It's been given the picture to denominate a certain amount of DVDs. So it says, on Monday, 24 DVDs were sold. How many DVDs were sold on Friday? So on Monday, we have this amount of DVDs. And like we said, it's not 3, it's actually 24. So we want to try and find out the value of just one of them, so that we can then use that knowledge to help us work out the Friday value. So if 3 make 24, 1 must be 24 divided by 3. And 24 divided by 3 is 8. So each of these picture of a DVDs is worth 8. So how many were sold on Friday? Well, we have 1 lot of 8, 2, 3, 4, 5, 6. 6 lots of 8, which is 48. But then we have this crafty little half. Well, what's half of 8? 4. So we're going to plus 4 equals 52. So on Friday, they sold 52 DVDs. Okay, question 10. It says a shop has an offer. We love an offer. Buy 1 box for £1.90, and then we can get the second box for half price. Woohoo! Okay. So, Ali buys 2 boxes of cereal. How much does he pay altogether? So he has to buy 2, so he's going to buy 1 at the full price of £1.90, and then he's going to buy 1 at half of £1.90. Well, what's half of £1.90? We could do a quick sum. We could do 190, which is 190 pence, divided by 2 would leave us with 95 pence, or £0.95. We could then add these together. 0 and 5 is 5, 9 and 9 is 18. Put back my decimal, 1 and 1 is 2. So the total price that he paid altogether for 2 boxes is £2.85. and we would get 2 marks for that because we showed our working. When you see this little sign here, show your method, make sure you do not just do it in your head. You must have some workings out on the sheet to get both marks. Otherwise, you're just throwing a mark away for being a genius. Question 11 says, write the missing values. Now, what can we see here? An equal sign. So we know that these fractions must be equivalent. 3/10 must be equivalent to something over 20. And again, we have an equal sign down here. So 12/15 must be equivalent to 4 over something. So how did I get from 10 to 20? I times by 2. So therefore I must do the same to the numerator. Times it by 2. 3 times 2 is 6. 3/10 is equivalent to 6/20. Similar on the bottom one, but the other way around, we're going to divide. How did I get from 12 to 4? I divided by 3. So what do I have to do to the 15? That's right, divide by 3. 15 divided by 3 is 5. So 12/15 is equivalent to 4/5. Okay, question 12. William has 4 parcels. And you can see the parcels have got different weights. 1.4 kilograms, 1,500 grams, 2 kilograms, and 300 grams. Then it says, write the masses in order, starting with the heaviest. And now we can see they've even put this word heaviest in bold. And it's even put it again down here. So we really shouldn't make a mistake of putting them in the wrong order from lightest to heaviest, because we have been given a lot of clues here. But what do we need to do first? Well, we have some kilograms and some grams. So we need to turn them into the same measurement. And I'm going to turn them all into grams, but you could do it the other way around. So 1.4 kilograms is 1,400 grams. We already have the 1,500 done for us. 2 kilograms is 2,000 grams, and 300 grams has already been done for us. So which one is heaviest? Well, we can see that the 2 kilograms is heaviest. Now, when we're writing our answer, I would suggest that you don't put 2,000 grams because the original box was in kilograms. So they might be lenient with you, but we want to make sure we're not going to make any small mistakes. So let's put 2 kilograms. Then which one was next? Well, 1,500 grams. And that's been written as 1,500 grams. After that was 1.4 kilograms. And last but not least, the little box, 300 grams. Be careful with that labeling. Okay, question 13, a graph. I love a graph question. It says, look at the graph below that shows Dev's bike ride. And we can see that we have along the x-axis, this axis here, we have the time that he's taken. And then along the y-axis, we have the distance that he has covered. So for example, we can see that in this 10-minute period, he covered 3 kilometers. Okay, but what's the question asking us? It says match each part of Dev's journey to the correct sentence. Okay, so A to B. So what happened between A and B? Well, we can see he started on 0 minutes and traveled 10 minutes. And he went, as we said just before, 3 kilometers. So we can see this one down here. Dev cycles 3 kilometers in 10 minutes. Let's link them together. Next one, B to C. Well, B to C, he waits a whole 10 minutes, but he actually doesn't travel anywhere, does he? Because he's not going up the y-axis. So I would say it's fair to say Dev takes a rest for 10 minutes. And then C to D, again, it's a 10-minute interval. And we can see this time, he actually only travels 1 kilometer up to the 4 kilometer mark. So Dev cycles 1 kilometer in 10 minutes. And then the last one has to be this one at the bottom here, but let's just check it. It says D to E, Dev cycles less than 1 kilometer in 10 minutes. Well, yes, we can see he doesn't quite get to the 5 kilometer mark here. He's a bit short, so that would be right. Cool, 1 mark. Question 14 says, this 850 milliliter bottle of squash makes 17 drinks. And then our question is, how many millimeters of squash are in each drink? Okay, so if the whole thing equals 17 drinks and is 850 milliliters, to find one drink, we could just divide our 850 by 17. Okay, so we're dividing by a 2-digit divisor, so let's put some multiples of this 2 digits so we can make it a bit easier. We're going to have 17, then 34, 51. I'm doing this in my head, but if you wanted to add them, you could. 68, and then 85. And then, oh, I can see something interesting here with our 85. I think that's going to come in handy. 17s into 8 goes 0 times, just carry that 8 across. 17s into 85, yep, go 5 times. And then obviously 17s into 0, don't go at all. So in each glass I would have 50 milliliters. Question 15 says write the correct sign. We either have equal to, greater than, or less than in each of these boxes. Okay, so we've got a lot of multiplication questions and a lot of addition questions, and that's the same all the way down. So what do we need to know? Well, we need to know that addition and multiplication are commutative, which means it doesn't matter which way around we put these numbers here, we're still going to get the same answer. So let's multiply it the easiest way. So 1 times 2 would be 2, times 3 is 6. So we have 6 on this side, and then 1 plus 2 is 3, plus 3 is also 6. So this one would equal. 2 times 2 is 4, times 2 is 8, but then 2 plus 2 plus 2 is actually just 6. So this side would be greater. Remember, if you're confused with these signs, the crocodile likes to eat the bigger value. Third one is 1 times 10 is 10, times 10 is 100. And then, well, I can see it's definitely going to be smaller on this side, but 1 plus 10 is 21. So therefore it's the same as the one above, greater than. Oh, this one is going to trick people because look, we have a 0. So 0 times 10 is 0, times 10 is also 0. So this side has a total value of 0. That's going to catch people out because I imagine some people are going to do 0 times 10 is 0, but then they'll do 10 times 10 is 100. Remember, this whole question is being multiplied by the 0. Anything multiplied by a 0 is 0. And on the other side, 0 plus 10 is 10, plus 10 is 20. So this side is less than this side. And we would get the full 2 marks. I imagine they're giving 2 marks because they're anticipating a lot of people getting this bottom one incorrect. Question 16 says tick the numbers that round to 28.7. Okay, so let's just remind ourselves that if we have a number with 5 or more, we will round it up. But then if the number has a 4 at the end or anything less, we will round it down. Okay, so 28.07, they're trying to trick us with this little 7 here, but this number would end up getting rounded to 28.1. Next one, 28.65. So we're looking at this 5 here, and what's it going to do to the 6? Well, it's going to round it up because we have a 5. So that would end up being 28.7. Well, that's what we're looking for, so let's give this one a tick, but let's not stop because it says numbers, so there might be more than one. This next one is 28.71, and 28.71 will get influenced by this 1, and that would round down, or keep it as a 7, so it would have 28.7, and again, give it a tick. 28.75, the 5 would impact the 7 and turn it up to an 8, so we would get 28.8, no tick, and 28.97 would end up getting rounded to 29. Again, no tick. So just these middle two would give us the mark. Question 17 says 6 divides into 40 with a remainder of 4. Write one other number that divides into 40 with a remainder of 4. Okay, well let's have a look what happens with 6 and 40 when we divide them. So 40 divided by 6 gives us 6 remainder 4 because we can only get to 36. 6 is a 36. So my magic number that I'm sort of aiming for is 36. Now you're really going to need to know your multiplication tables here to help you, because actually therefore what we're looking for is another number that is a factor of 36. So let's do our factors of 36. We have 1 and 36, 2 and 18, 3 and 12, 4 and 9, and 6 and 6. Now if I look at these factors, I might be able to find some options. Let's start by looking at this 36. Well, if I try and divide 40 by 36, I'm going to get 1 remainder 4. That would be an option. So I could put 36 as my answer. Let's see if any others work. 18. 40 divided by 18. Well, 18 times 2 is 36. So we know that 40 divided by 18 is going to be 2, remainder 4. So that would work. I think 12 would too. 12, 24, 36. With again 4 left over. 9 would work, and also 6 would work, but they've already done 6. So any of these 36, 18, 12 or 9 would be a correct answer. Question 18 says this sign shows the number of empty spaces, and again it's put in bold to remind us this is important, on each level, I would quite like that in bold as well, of a car park at 10 a.m. So you can see that level 2 has 511 empty spaces and level 1 has 268. In this car park, each level has 800 spaces. What is the total number of cars parked in the car park at 10 a.m? Well, this is our empty spaces. So we can't just add these two numbers together. We need to find out how many people are actually in the parking bays. So let's do level 2 to start with. Level 2 has 800 bays. 511 are free. So if we subtract the 511, we're going to get how many are taken. Now I could try and do this in my head, again to try and save time, but if I want to use this column subtraction I can. So on level 2, we have 289 people parked. Okay, level 1. Level 1 again has 800 bays and there are 268 of them. So there are 532 people parked on level 1. But now I'm not finished because it said what is the total number of cars parked in the car park. So now I need to add these together. 9 and 2 is 11. 1 plus 8 is 9 plus my 3 is 12. 1 plus 2 is 3 plus my 5 is 8. So in total there are 821 people parked. And again, look, we have that 2 marks and showing your method. So we kind of know this is going to be a bit of a longer question. So if you're breezing through this and you get a question really quickly, maybe question yourself and just ask, hang on a minute, have I done this right? Go back and read it again. Question 19. The circumference of this circle is 60 centimeters. And it says here, not actual size. Now question, what is the distance around the edge of the circle from A to B? So this distance just here. Well, at first glance, it might look like we don't have enough information to work this out, but I can see it's only 1 mark, so it's not going to be too difficult. So there must be a clue here to help us. And I think I can find it. Here we go. In the middle here, we are shown that this angle here is a right angle. So if we know that this is 90 degrees, we know that a full circle is 360. So 90 degrees is 1/4 of that 360. So therefore, 1/4 of the total circumference, which is 60, is going to equal, well, what's 1/4 of 60? We can do 1/2 of 60 is 30, and another half of that is 15. So the length of A to B is 15 centimeters. So this is straightforward as long as we understand some basic geometry. Okay, question 20. And question 20 says there are 432 places at a dance school. There are 2 age groups. This table shows the number of classes and the number of pupils in each class for each age group at the moment. So we can see in the ages 7 to 9, we have a total of 15 classes and 16 people in each class. So if we're wanting to work out how many 7 to 12-year-olds go, we would therefore have to multiply the 15 classes by the 16 people in each class. That will give us the total of that age range. And again, same thing for the 13 to 18-year-olds. If we got the 10 classes and multiplied by the 18 people in each class, we would get the total amount. And my question says, how many more pupils can join the dance class? So the whole dance class can occupy 432 people. This is going to be a key number for us. Let's put it here. So we want to know how many people are going already, and then we're going to see the difference between that and our capacity to see how many extra spaces there are available. Now we have a couple of options for this multiplication, but again we're going to think about time, and I'm going to do this in the quickest way. So 15 times 16 is the same as saying 16 times 15. And I'm going to distribute this a little bit differently now. I'm going to say instead of 16 times 15, I'm going to do 16 times 10. 16 times 10 equals 160. And then I'm going to do 16 times 5. 16 times 5, which will be just half of the 160, is 80. Add the two together, 160 and 80 equals 240. So in the 7 to 12 category, we have 240 people. Second one's a bit easier, it's just 10 times 18, which therefore equals 180. So in the 13 to 80s, I have 180. But I'm not done yet. I'm going to find the total amount of people going. Let's add these two numbers together. 0 and 0 is 0. 4 and 8 is 12. 2 and 1 is 3, plus the 1 is 4. So we have a total amount of 420 going and 432 spaces. So if we can't see this in our head, we could do 432, subtract 420, and that leaves me with 12. So I have 12 spaces available. Question 21, this is another great one. Each shape stands for a number. So these triangles and these circles, they have a quantity value. The total of the shapes on the diagonal line is 48. So this triangle added to this triangle added to this triangle equals 48. The total of all the shapes is 200. Calculate the value of each shape. So we want to find out what one triangle is worth and what one circle is worth. So where can we start? Well, they've clearly given us a big clue with telling us the total of the shapes on the diagonal line is 48. So if 3 of my triangles equal 48, to find one, I'm going to do 48 divided by 3. And 48 divided by 3 gives me 16. So each triangle has a value of 16. So I can put that into my answer straight away. Okay, but how am I going to work out the circle? Well, we know that the whole total is 200. So if I take away the 16s, we have a 16 here, a 16 here, 16 here, a 16 here, and a 16 here. If I take away all those 5 16s, I'm going to be left with the total amount of the 4 circles. So let's do that first. Now I could just do minus 16, and again, minus 16, minus 16, but I'm not going to do that. I'm going to do quicker method. I'm going to do 16 times 5, which I know is 80. So now I can do 200, subtract this 80, leaves me with 120. So my 4 circles together equal 120. So how am I going to find out what one circle is worth? Well, I'm going to do my 120 divided by 4. And it's a bit like quartering, isn't it? So I could just do half and half again. So my answer for the circle value is 30. If I was really not sure, I could then add all these up and just make sure I get the 200 that I was looking for. Question 22 says you can make green paint by mixing 250 milliliters of blue paint and 1,150 milliliters of yellow paint. And I dare you to go and do this after watching this video at home in your living room. Parents, thank me later. Then it says Stefan wants to make some of this green paint. But Stefan uses 750 milliliters of blue paint. He must need a lot. How much green paint does he need? Okay, so this is our ratio. We need 250 milliliters to every 1,150 milliliters. Stefan has done 750 milliliters of blue. So how much extra has he used? Well, we've got 250 and he used 750. I can see a relationship here of times 3. So if he's times the blue paint by 3, guess what? He's also going to have to times the yellow paint too, which is 1,150 times 3. Now, because I'm a genius, I can do this in my head. I'm going to do 3 lots of 50 is 150, 3 lots of 100 is 300, and 3 lots of 1,000 is 3,000. So I get an answer of 3,450. But if you wanted to, you could put them into column addition or even a multiplication. 1,150 times 3. 3 times 0 is 0. 3 times 5 is 15. 3 times 1 is 3, plus the 1 is 4. 3 times 1 is 3. But that's not my end of my question, is it? The actual question says, how much green paint does he make? So I've got 750 milliliters of blue and 3,450 milliliters of yellow. So I'm going to have to add them together. 750 and 3,450, which is going to be 4,200 milliliters. Okay, we're getting super close to the end now. Question 23. Question 23 says, Adam has a bag of fruit that weighs 1.25 kilograms. And then it says he takes out a banana. Now the bag of fruit weighs 1.1 kilograms. Next, he takes out an orange. Now the bag weighs 920 grams. But then here's the question. How much more does the orange weigh than the banana? Oof, this is going to be a bit of a tricky one to work out. We're going to show our method is worth 2 marks, so we know we're going to have some multiple steps here to do. Right, first things first. He takes out the banana. Now the bag of fruit weighs 1.1. So the difference between the 1.25 and the 1.1 is going to be the weight of the banana. Let's do that first. 1.25 subtract 1.1. Put back our placeholder, make it 1.10. 5 subtract 0 is 5. 2 subtract 1 is 1, decimal, 1 subtract 1 is 0. So my banana must weigh 0.15 kilograms or 150 grams. So now we need to work out how much the orange weighs. So we can see that it says next he takes out an orange. So the bag was weighing 1.1 kilogram now, which is 1,100 grams. And he takes out the orange and it now weighs 920. So if we subtract that 920 away from the 1,100, we're left with 180. So therefore my orange must weigh 180 grams. But again, we're still not finished because the question says how much more does the orange weigh than the banana? So some of you will be able to just see in your head that the orange weighs 180, the banana weighs 150. So it should be 30 grams more. But let's check by doing 180, subtract 150, that equals 30 like we thought. Good, 30 grams. Penultimate question now, our second to last question, and it says here is an isosceles triangle inside a rectangle. So a few clues there already. It says calculate the sizes of angles X and Y. So you can see X here and Y here. We don't have the angles for us. But we have clues to help us. So an isosceles triangle must have 2 equal angles. So this angle will be the same as this angle. Therefore, we can use our knowledge of triangles and understand that a triangle equals 180 internal angle. So if I subtract my 30, I'm going to be left with 150. So these 2 angles together equal 150. Therefore, one on their own equals 75. So my X angle here equals 75 degrees. So I can put that in my answer already. So then what does my Y equal? Well, we have already established this angle here is 75 degrees. We know that this is a rectangle, so this must be a right angle. Right angles measure 90 degrees. Subtract my 75 away and it leaves me with 15 degrees. So Y equals 15 degrees. Pretty easy considering how hard it looks. Okay, and the last question says the triangle can be transformed on the grid as follows. First, translate the shape 7 units down. Then reflect the resulting triangle, so not the first triangle, the second triangle, on the y-axis. And it's been very kind to give us the labels, so we know this line here is the y and this line here is the x. Draw the new triangle on the grid after each transformation. So it doesn't just want you to put the final triangle, you've got to do each of its transformations. So first one said translate the shape 7 units down. So we can make a mark on all of these corners and then we're going to move them 7 down. So 1, 2, 3, 4, 5, 6, 7. This will be the first one. Next one I'm going to do this top one. 1, 2, 3, 4, 5, 6, and 7. So this is going to be my top triangle. And then the last one, 1, 2, 3, 4, 5, 6, 7. There's my last corner. Now, it says very clearly, but a little bit hidden, use a ruler. Now, if you're like some of the students in my classes, sometimes we can pretend our ruler is like a hot iron and we don't want to use it. But it says to use a ruler, and in questions like this, you must use a ruler. So I can't really use a ruler myself, but you're going to. So I'm going to draw my triangle as neatly as I can. Not bad, I hear you saying. Yep, pretty good. Okay. And now we can just do a few little things just to check that we've done it correctly. Well, on this first one, this point was only 1 square up to this point. And again, that's right. Same as mine. And this point was 1, 2, 3 points further down than that point. So 1 and then 1, 2, 3. Good. So I've done everything correct so far. Now it says reflect the resulting triangle in the y-axis. So it wants me to use this line here to reflect. Now remember, when we're reflecting, all I'm going to do is I'm going to count how many each of the corners is away from the line I'm reflecting on, in this case the y-axis. So this point is 1 away, so I'm going to put it 1 away on the other side. Not here. Some people are going to put it here because they're not going to see this first line as a line. But this is where it would go. This one will again go 1. And then this one is going to go 1, 2, 3, 4, 5. So I'll go 1, 2, 3, 4, 5. There we go. Now I can draw my final triangle nice and neatly using a ruler. And I would get my 2 marks. And there we go. That is the end of the test. So depending on whether you did this yourself beforehand or if you've just done a walkthrough with me, you can decide for yourself how well you've got on. If there's any questions you struggled with, go back to that question, re-watch it again and just try and watch it until you understand it. If you're still struggling with it, find that unit and watch the full video on my channel as well. Hopefully this video has been useful for you guys, and really good luck for you all in your upcoming SATs. Let me know how you do in the comments section. But for now, I'm going to see you in another video. Peace out. What is up everybody, and welcome back to the Maths Guy. Today we're going to look at the 2022 SATs Maths paper, paper 3, Reasoning. If you haven't checked out paper 1 and 2, you can see those on my channel as well, and I'll link them in the description. So let's begin by just looking at the instructions. This is a non-calculator test, and we have 40 minutes to complete it. It says that we can do our workings out around the question or in the question box, but do not write on any of the barcodes. So let's begin with question 1. It says here is a drawing of a hexagonal prism, and then the question says how many faces does the prism have? Well, let's think about what we know about a hexagon. A hexagon has 1, 2, 3, 4, 5, 6 sides. Therefore, it's going to have 6 edges all the way around. We're going to have 1, 2, 3. And then on the back side, the ones we can't see, we're going to have 4, 5, and 6. But then we also have this front face for 7 and the back face for 8. So how many faces does our prism have? We have 8. Question 2 says here are 6 number cards. And the question says, use all 6 cards to complete the 3 multiplications below. And it's even put it in bold that we're going to use all 6 cards. So let's use this space next to the question to see any of the possible solutions. So how can we get to 24? Well, to get to 24, we could use 3 times 8. So I could have 3 times 8. But I could also have 4 times 6. 4 times 6. So we won't complete that one yet. Let's have a look at 28. How are we going to get to 28? Well, there's actually only one solution to get to 28. We would have to multiply 7 times 4. And then to get to 30, I would do 5 times 6. So because I've used my 4 and my 6 here, I now can't use this question. So I'm going to have to stick with 3 times 8, 7 times 4, and 5 times 6. Does that use all of our numbers? Let's just check. 3, 8, 7, 4, 5, and 6. Yes, it does. The trick of this question would have been this first one, making sure that we actually understand that there were 2 options and making sure that we pick the right one with the numbers that we had left. Question 3 says, Olivia buys a banana, an apple, and a bag of nuts. She pays with 3 50p coins. What is her change? Okay, so let's first work out how much she spent. So her banana was 30p, her apple was 45, and her nuts were 60. So let's add those together. We have 30 plus 45 plus 60. Starting our units, 5 plus 0 is 5. 3 plus 4 is 7, plus 6, 13. So I have 135p that's been spent, or £1.35. But it wants to know how much she has as change. And she paid with 3 50p coins. Well, 3 times 50 is 150. So if we have 150, subtract my 135, 0 subtract 5 I can't do, so I'll have to borrow from next door. 10 subtract 5 is 5, 4 subtract 3 is 1, 1 subtract 1, 0. So her change would be 15p. And again, noticing that it says show your method, so it wants to see our workings out to get the full 2 marks. Okay, question 4. says draw 4 lines to match each fraction to its equivalent decimal. So we obviously have got 4 fractions here, 1, 2, 3, 4, but we have 6 decimals, so obviously only some of them are going to match. So we need to be careful here. Let's look at our first one, 1/2. Well, 1/2 is equivalent to 0.5, so I'll draw that line across. Then we have 3/10. 3/10 is saying that we have a 3 in the tens column, so drawing out my place value charts, ones, tens, decimal, tenths, and 3/10 would have a 3 in the tenths column. Put my decimal on my 0 in place, and I have 0.3. So 3/10 is equivalent to 0.3. 3/4, this is one of the ones that we should just know off our head. 3/4 is the same as saying 0.75. And 3/100ths is now saying that my 3 is in the hundredths column. So let's put my hundredths, put my 3 in place, fill in the placeholders, and I'd have 0.03. There it is, match them across. And this question was worth 2 marks. Question 5. Some children vote for their favourite ice cream flavour. And we have the ice cream flavours here, vanilla, chocolate, strawberry, mint. Mint would definitely be my favourite. And then we have the number of children that voted. 87 for vanilla, 154 for chocolate. We don't know how many for strawberry. I imagine that's going to be part of the question. And 38 for mint. But we have the total, and the total is 402. How many children voted for strawberry? There we go, that's the question. So if we have the total of 402, what we could do is we could subtract the sum of everything else. So let's do that first. We're going to add up our 87, our 154, and our 38. So I'm going to do that over here. 7 plus 4 is 11, plus my 8 is 19. 8 plus 5 is 13, plus my 3 is 16, plus my 1 is 17. And then 1 plus my new 1 is 2. So between every other flavour, we had 279 children, but the total was 402. So to find the missing value, I'd have to subtract my 279 away from my 402. And that will give me the missing value of strawberry. So let's do that. 2 subtract 9 we can't do. And if we look next door, we actually have nothing next door. This is a very classic SATs question where we can't borrow immediately from next door. So we have to look again and borrow from the next door. So let's put this 4 down to a 3 and put a 1 in my tens column. Now my 2 can look next door, look at the 10 and put it down to a 9. Borrowing a whole 10, making it a 12. Now I'm ready to begin. 12 subtract 9 is 3. 9 subtract 7 is 2. And 3 subtract 2 is 1. Leaving my total answer for the amount of people that chose strawberry as 123. And I would get both marks. Don't be afraid at this point to use this extra space around the answer box if it's more helpful. I like to spread my work out and really use the space available, but some people prefer to write in these boxes. Either is fine. Okay, question 6 says this chart shows the range of temperatures each day during 1 week from Monday to Friday. We have the temperature across the bottom and we have the days going across our chart. Then question 1 says what is the lowest temperature? Well, looking at our numbers, we have positive values over here and more negative values on the left hand side. So looking at my negative values, I can see we have a -8, but no day reaches -8. I have a -6, and we have Friday and Tuesday that go past -6 onto this spare line here, which would therefore be -7 between the -6 and -8. Again, another very classic thing that they like to do on SATs papers, where they give you a chart with missing values. Some people like to fill those values in, so I might do that now. -5 here, -3, -1, 1, 3, 5, 7. That'll just help me avoid making any more small mistakes. So what is the lowest temperature? We have -7. Question 2 says, what is the difference between the highest and the lowest temperature on Wednesday? So we're only focusing on Wednesday, and it wants to know the difference between the highest and the lowest. And I bet we're going to use those missing values again. Yes, we are. Look. So Wednesday, the lowest value was this one here, -5. And the highest value, again, one of our missing values, was at 3. So how do we get from -5 to 3? Let's draw a number line. -5, negative 4, negative 3, negative 2, negative 1, 0, 1, 2, and 3. Let's see how many jumps that was. 1, 2, 3, 4, 5, 6, 7, 8. So our differences between the highest and the lowest temperature on Wednesday is 8 degrees, and we would get both marks. Question 7 says, on Saturday afternoon, a total of 234,869 people attended 3 rugby matches. 80,978 people attended match 1. 72,319 people attended match 2. How many people attended match 3? So let's look at this with a quick bar model. We have a total of 234,869. On match 1, we had 80,978. Match 2, let's see if I can squeeze this in, we had 72,319. And we're looking for how many people were at match 3. So again, it's that missing value question. So our first step is we're going to find the total of the values we know. So let's add 80,978 to 72,319. So my total for match 1 and 2 was 153,297. But we still don't know this missing value. So essentially what we've got is 153,297 plus something equals 234,869. So now we can simply just use inverse, and I can say that 234,869 subtract 153,297 must equal my question mark. So let's do that now. I have 234,869 subtract 153,297. Don't be put off with these big numbers. It's not much harder, it's just a little bit longer. So my total answer for the amount of people that turned up to match 3 is 81,572. And I would get my 2 marks. Now again, notice how much space I've used around this question to answer this question. Don't be afraid to use the paper that is in front of you. Question 8, and we're going to look at a bit of rounding now. And our number that we're going to be rounding is 7,546. First one says, round to the nearest 1,000. So 7,546. And let's label it. This is our thousands, our hundreds, tens, and ones. So when we're rounding to our nearest thousands, we need to look next door to see how it's going to be influenced. And if we remember, if our number is 0, 1, 2, 3, or 4, we're going to leave that number alone and not round it up. But if it's 5 or more, we will let it soar. We'll round it up. And as we can see, we have a 5. So that 5 is going to make our 7,000 round up to an 8,000. So to the nearest 1,000 would become 8,000. Now it wants us to round it to the nearest 100. So if I'm rounding to the nearest 100, I'll underline it and look next door. This time we have a 4. So the 4 is not big enough to round our 5 up. So we're going to keep it as a 5. So rounding it to the nearest 100 would be 7,500. And then rounding to the nearest 10, we're going to underline our 10 and then look next door. And we can see we have a 6, which is greater than 5. So the 6 is going to influence the 4 and bump it up to a 5. So I'll end up with 7,550. So in the question like this, as long as we understand our method of if we have a 5, 6, 7, 8, or 9, we round the number up. But if we have a 4, 3, 2, 1, or 0, we would leave the number as it is. Question 9 is wanting us to look at this equation. It's an equation because we have this equal sign and we have two things either side of it, but we have this missing value. So what it's saying is that 1,000 times 416 is equivalent or the same as saying 10 times something. So let's first work out this side of the equation first. 1,000 times 416. Well, we're going to use our place value knowledge and know that if it's 416 times 1,000, we're going to end up with 416,000. If I wanted to draw my place value chart out, I could. Let's have ones, tens, hundreds, thousands, 10,000s, 100,000s. And I started with 416, but I'm timesing it by 1,000. So I'd need to move it 1, 2, 3 places. So 1, 2, 3 brings the 4 into the 100,000, the 1 into the 10,000, the 6 into the 1,000, and I'd put my placeholders in place, 416,000. But we've not finished because that means it's got to be equal to 10 times something. Well, what must we multiply by 10 to get to 416,000? Well, to do this, we can just get our 416,000 and divide by 10, which gives us 41,600. So my 41,600 when times by 10 will equal 416,000. So my final answer is 41,600. Question 10. Adam buys 4 pens and a ruler and pays £4.75 altogether. So our 4 pens and 1 ruler equals £4.75. Then it says Jack buys 2 pens but only pays £1.98 altogether. How much does the ruler cost? Okay, so we've got a little bit of working out to do here. So because Adam has 2 variables, because he's bought pens and a ruler, we're not really going to be able to use Adam to help us find out what each of these values is worth. But Jack has only bought pens, and he bought 2 of them for £1.98. So to find out how much 1 pen is, we can just divide our £1.98, or 198 pence, by 2. So let's do that first. How many 2s are in 1? 0. How many 2s are in 19? 9, with 1 left over. How many 2s are in 18? 9. So each pen costs 99 pence. So now we can use that knowledge to help us work out how much the ruler costs. Because Adam bought 4 pens. So let's see how much he spent on pens. If each pen is 99 pence, we're going to do 4 times 99. I can do that in my column method. 99 times 4. 4 9s are 36. And again, 4 9s are 36, but plus my 3, 39. So I have £3.96. So he spent £3.96 on just his pens. So therefore, the difference between his total, which was £4.75, subtract how much he spent on the pens, which was £3.96, is going to give us the ruler price. So let's see how much that was. 5 subtract 6 we can't do. Let's borrow from next door. 15 subtract 6 is 9. 6 subtract 9 I can't do. Borrow from next door again. 16 subtract 9 is 7. 3 subtract 3 is 0. So how much did he spend on the ruler? The answer is 79 pence. Loads of working out, but that's not the only way we could have done it. What we could have said is that we know Jack buys 2 pens and Adam bought 4 pens. So if we get this £1.98 and we times it by 2, we would automatically get our £3.96. And then again, we could just subtract that from the total of £4.75 and it would give us the same answer. So 2 different methods, but to get you the same answer. Let's have a look at question 11. Ali chooses a whole number. When she multiplies her number by 4, the answer is less than 100. When she multiplies her number by 5, the answer is greater than 100. Write a number that Ali could have started with. Okay, we've been given loads of information here. So we know that she's chosen a whole number. That's our first clue. Then we know that when she multiplies her number by 4, so let's put a question mark for her number. When she multiplies it by 4, we get an answer that is less than 100. But then, when she multiplies her number by 5, she gets an answer that is greater than 100. So let's use a little bit of trial and error to get us there then. Let's start with just the number 10. Let's do 10 times 4 equals 40. So that's right, that's less than 100. But then 10 times 5 only equals 50, and that's not greater than 100. So it's not going to be 10. We need to pick something larger. Let's try 20. 20 times 4 equals 80. That's right, that's less than 100. 20 times 5 equals 100. Well, 100 is not greater than 100, so that is wrong. But we know we're now close. Let's try 25. 25 times 4 equals 100. Well, 100 is not less than 100, so we know that's wrong straight away. So our number is somewhere between 20 and 25. Let's do 21. 21 times 4 equals 84, but 21 times 5 equals 105. So 21 times 4 is 84, that's correct, that's less than 100. And 21 times 5 is 105, which is greater than 100. So we could have 21 as an answer. But there are multiple possibilities because 21 fits between this gap here, but there are other numbers. We have 21, 22, 23, and 24. And I think all of those numbers are going to work. Let's check. So we know 21 works. Let's check the other extreme. Let's try 24. 24 times 4 equals 96. That's good. That's less than 100. 24 times 5 equals 120. That's good. That's greater than 100. So 24 would work too. Therefore, we know everything between 21 and 24 would work. So we could have any of these four numbers, 21, 22, 23, or 24. Trick to this is to use a bit of trial and error. Start with a number that makes sense to you and then just go from there. Question 12 says, William says the rule for this diagram. Find the difference between the numbers in the circles. Double this to make the number in the square. And then it says use the same rule to write the missing numbers below. So finding the difference between the numbers in the circles, so the difference between 5 and 20 is obviously 15. And then double this to make the number in the square. So we will double that to get the number in the square. That makes sense that that would then be 30. So let's use the same rule to work out these questions below. So what's the difference between 32 and 100? Well, I know it's 68, just on the top of my head, but if you wanted to use column subtraction, you could. You could do 100 subtract 32. But then it says I need to double my 68, and doubling 68 gives me 136. Again, you could times that by 2 or add two 68s together if you wanted to. But our second one is a little bit harder because now we have to come backwards. So if we know we're doubling when we're coming this way, we're obviously going to halve when we're coming the other way. So what's half of 400 equals 200. So therefore the difference between these two circles is 200. So I'm going to be adding 200 to my 110, leaving me 310. A little bit confusing, particularly on that second one where we come backwards. But understanding doubling and halving here would really help us. Okay, jumping into question 13 says, write the missing fraction to make this addition correct. So we can see that this is an addition question and we have a missing fraction. So let's look at what we know. We know that the answer is going to be 5/6. But the start of our question is 2/3. So we have different denominators. We have a 3 and a 6. And we know when we are adding fractions, we must have the same denominator. So what we're going to do is we're going to find an equivalent fraction to this fraction, but with a 6 as a denominator. So how can I get from my 3 to a 6? Well, I would have to multiply by 2. Therefore, whatever I do to the denominator, I must do to the numerator. So 2 times 2 is 4. So now my equivalent fraction to 2/3 would be 4/6. So I can get rid of this now and work with 4/6. So now my question says 4/6 plus something equals 5/6. Well, hopefully we can see that 4/6 add 1/6 would equal 5/6. If this was a bit trickier and I couldn't see that in my head, I could just do the inverse and do 5/6 subtract 4/6 equals 1/6. Same answer. I'm going to make sure I put my answer actually in the answer box just to be sure. Okay, question 14 says Jack hires a hall for a party. This formula is used to work out the total cost. And it says the total cost equals a £15 booking fee plus £12.50 for every hour they use the hall. And then it says what is the total cost of hiring the hall from 6 p.m. until 11 p.m. So let's first work out how many hours we're going to be in the hall. And if we're going from 6 till 11 p.m., that equals 5 hours. So now we can start to write our formula a little bit. So our cost, let's put a C, equals 15, because we know we're going to have to pay this £15, plus 5 times £12.50, because we're going for 5 hours and it's going to cost £12.50 per hour. Let's work out this part of our formula first, because following BODMAS we must always do multiplication first, and because we want to work out how much the total for the amount of hours is. So let's do 5 times £12.50. So I'm going to put my £12.50 and multiply by 5. Now when we're multiplying by a decimal, we can just ignore this decimal just for now, and we'll put it back at the end. 5 times 0 is 0, 5 times 5 is 25, 5 times 2 is 10, plus my 2 is 12, and 5 times 1 is 5, plus the 1 is 6. Put back my decimal, and my total cost for the hours is £62.50. So let's do the next line of my formula. The cost equals £15 plus the total cost of the hours, which is £62.50. Now I simply just add this up. £62.50 plus £15. Add that up. So my total cost equals £77.50. Make sure I put it into the right box. And I'm good to go. Question 15 says Stefan stands in the center of this square. So Stefan is standing right here. Stefan is facing F. So at the minute he's facing F. He turns anti-clockwise. So let's just remember that anti-clockwise comes back along the clock face like this to face D. So now he's facing D. What angle does Stefan turn through? So he's gone from this point here to this point here. So therefore he's gone from this line to this line, and we can see that those two lines are making a right angle, and therefore right angles are 90 degrees. Hopefully we know that right angles are 90 degrees. Might look a little bit different because maybe we're used to seeing right angles like this or like this, and this one is obviously at an angle, but it's still a right angle. Then it says Stefan is now facing towards D. Now he's facing here, and he turns 3 right angles clockwise. So clockwise would be this way. Write the letter he faces after the turn. So he's gone 1 right angle, 2 right angles, and 3 right angles. So if he's gone 1, 2, 3, he's now facing this line here, which is B. So we'll put B as our answer. And let's move on to question 16. Part of this 10 by 10 grid is shaded. We can see this is a 10 by 10. We have 10 squares across the top and 10 squares down the sides. Tick the fraction that represents the shaded part of this grid. And they've tried to trick us because they've shaded different positions rather than all next to each other. But we have 10 shaded here, another 10, another 10, and another 10. So we have 40 that's shaded. There was 100, so we have 40 over 100. So I can tick my 40 over 100. But look what I've noticed. I've noticed 2 marks, and it says tick the fractions with an S. So there must be another one here. Well, it's not going to be 1/4, because 1/4 would be 25 over 100. It's not going to be 6/10, because 6/10 would be 60 over 100. What about 4/10? Well, 40 over 100 would be equivalent to 4/10, wouldn't it? Because we've divided by 10 on both the numerator and the denominator. So 4/10 would be, and I think this is where people are going to make a mistake, because they've now found 2 and they're going to think, great, move on. But actually, let's have a look at 2/5. Because if we have 4/10, if we divide our 4 by another 2, and then we divide our 10 by another 2, we get 2/5. So therefore 2/5 is also an equivalent fraction of 40 over 100. So it would be 2/5 as well. So we actually have 3 fractions here to make the correct answer. This is a tricky one. I think a lot of people are going to forget the 2/5. Question 17. Kim makes a cuboid model using straws. And we have the length, the width, and the height given to us. And then we have some information. She uses straws that are 7.5 centimeters in height. So we know this height is 7.5. She uses straws that are 11 centimeters in length. And she uses straws that are 8.5 centimeters long in the width. What is the total length of all the straws in her model? Okay, so we've got a bit of work to do here. So the first job is identifying which straw is which. Let's start with our lengths. So this is one length, but then also this would be a length. And then I have 2 lengths on the back side as well, 1 and 2. So in total, I have 4 lengths. So I'd have 4 times 11. Now let's have a look at these widths. Well, I have 1 width here. I have 1 width here, that's 2, 3, and 4. So again, I have 4 times 8.5 this time. And then let's have a look at the heights. I have 1, 2, 3, and 4 heights. So I would have another 4 times 7.5 this time. And then when I add all of those together, I should get my total. So let's do that right now. And I'm going to try and do this in my head. 4 times 11 is 44. 4 times 8.5, well, I'm going to do 4 times 8. 4 times 8 is 32. And then 4 times 0.5 would be 2. So that would give me a total of 34. And then the last one, 4 times 7.5, well, 2 times 7.5 is 15. So therefore, 4 times 7.5 is 30. Remember to try and use any mental maths you know to try and help you, because we are under time pressure. Now I can just simply add these up. So my total is 108 centimeters. But there is another way. Because we know we have 4 of each of them, what we could do is just get a total by adding the 7.5 to the 11 and the 8.5. So let's do that. Gives me 27. And then if I times my 27 by 4, 4 times 7 is 28. 4 times 2 is 8, plus the 2 is 10. Gives me the same answer. So my total, 108 centimeters. Question 18, and a classic SATs exam question. We have a percentage discount. So this shows a sale, and this t-shirt is reduced by 30%. The full price of the t-shirt is £15. The price is reduced by 30%. What is the reduced price? Okay, so let's do this in stages then. And what we can always do is try and find 10%, because 10% of something is easy to find because we can just divide it by 10. Therefore, 10% of £15 would be £1.50. And if you can't see that, you can use your place value chart to help you. So if 10% is £1.50, then all we need to do to get to 30% is times our £1.50 by 3. So therefore 30% of 15 is £4.50. Again, if you couldn't do that in your head, use your written calculations. But that's not finished. This is how much the t-shirt was reduced by. But it asked me for what is the reduced price. So what's the new price? So it was £15, and we're subtracting £4.50 away. So let's do that then. 0 subtract 0 is obviously 0. 0 subtract 5 we can't do, so I'm going to have to look next door. 10 subtract 5 is 5. 4 subtract 4 is 0. And 1 subtract nothing is 1. So my total price after the reduction of 30% is £10.50. Okay, question 19. We're getting very close to the end. Bear with me. Here we go. Question 19 says, Jack says, when you square a prime number, the answer has only 2 factors. Explain why Jack is not correct. So they've been kind enough to tell us that Jack is not correct here, but we need to explain why. Well, first of all, what is a prime number? Well, a prime number is a number that only has 2 factors. For example, 7 only has a factor tree of 1 and 7. There's nothing else that can be multiplied together, no other integers, whole numbers that can be multiplied together to get the answer 7. But Jack has said that when we square this prime number, we will still only have 2 factors. So let's square 7, and 7 squared is 49. Well, now 49 has the factors 1 and 49, but it also now has 7 and 7, because it was 7 squared that actually made the number 49. So therefore, if we square a number, we're automatically giving it another set of factors, or another factor. But we need to explain this a little bit. So we can say that a prime number equals 2 factors, and if we square a prime number, we get 3 factors. Hopefully you can see that, because just by definition, if we square a number, we're automatically giving it another factor, because we're multiplying it by the 7s, and that would work with any prime number. Question 20. This table shows how many people finished the New York Marathon in each of the first 4 decades it was held. A decade being 10 years, but I don't think we need to know that. So in the first decade, we can see 24,863 people finished. Then it went up to 170,932, and then 282,420, and then finally in the 4th decade, 350,824 people completed it. Then it says, what is the mean number of people who finished the marathon per decade? Round your answer to the nearest 100. Wow, we've got loads to do here. And you can see for the first time we have 3 marks available. Whoa, that is a big indicator that we've got loads of work to do. So first of all, what does mean equal? If we don't know that, we're going to struggle. So the mean equals the average. So it's asking us to find the average of these 4 quantities. And to do that, what we're going to do is we're going to get the total, and then we're going to divide it by how many there are, which is 1, 2, 3, 4. And that's going to give us our mean. So let's do that first. I've got 24,863 plus 170,932. Being very careful of putting my numbers in the correct columns. Then 282,420. And then 350,824. Definitely worth at this point just checking that we've written the right numbers. This could be a very simple mistake we make that could throw everything else off. Now we've done loads of column addition today, so I'm just going to put the answer in, 3, 2, 1, and that gives me a total of 829,039. Okay, so that's my total, but now I need to divide it by 4 to get my average. So let's do that. 829,039 divided by 4. How many 4s are there in 8? It's 2. How many 4s in 2? 0, but that means I must roll my 2 across. How many 4s are there in 29? There are 7 with 1 rolled over. How many 4s are there in 10? There are 2 with 2 left over. How many 4s are there in 23? There are 5 with 3 left over. And then how many 4s are there in 39? Well, there are 9 with 1 left over. So we have a remainder, but that shouldn't matter because we're rounding our number to the nearest 100. So let's put our number over here. So that's the average, but we're rounding it to the nearest 100. So where's my 100 column? Well, I have 1s, 10s, 100s. So this is my 100 column. So I look next door and see the 5 influences this 2 up to a 3. So my answer would be 207,300. And then I'll put my answer in the correct box. And that'll get me all 3 marks. Tough question there, particularly if you don't know what mean means, because that is obviously really important. Good tip at this point is to look at how many marks you're offered for the question. If you are offered 3 points, that means the question is going to be big. So be prepared to do lots of working out. And finally we're here. Question 21, the last question. This says, these 2 rectangles are identical. So let's call this A and let's call this B. The lengths of each rectangle is 3 times its width. So the length equals 3 widths. But it's not drawn to scale, so we can't do anything like get our ruler out or anything like that. What is the coordinate of point P? Now this is only offering us 1 mark, so it mustn't be as tricky as it sounds. Let's have a look at what we do know. Well, we've been given no measurements actually on the graph itself, but what we have been given are 2 coordinates here. We know that this point is 0 to 1, and we know that this point here is -2, 8. So if this is -2,
along the x-axis, that therefore means that this width here is actually 2. And this is the clue. Now we know that the width is 2, we know that the length is 3 times the width. So the length must equal 6. So the width is 2 and the length is 6. Now we can start to fill in some of the details. So therefore this measurement here is 6, this measurement here is 6, and this measurement here is 6. And this would be 2. So I think we can do our x-axis by looking at our point P, coming along our length. We know we're coming 6, so therefore this P must be at 6 on the x-axis. But where is it on the y-axis? Well, we've got 2 here, but then we've also got another 1 here that's shown by that little mark there. So therefore 2 plus the 1 is 3. So my coordinate of P is 6 and 3. And this was all doable by working out that this measurement here is 2 and finding our clue. So whenever you see anything like this, there will always be a clue. You've just got to try and find it. And there you go. Can you believe it? We have now finished our test. And this was the 3rd test of the 2022 SATs. So we've now completed all of the exams. Hopefully this has given you a really good understanding of what to expect in the next exams coming up. I really hope this has been helpful for you. If it has, think about subscribing to the channel because we're going to be making daily videos to help you get through your SATs exams. If you want to take it super seriously, you can join my free course, where the link is in the description below, that goes through everything you're going to need to know to pass your Year 6 tests, with video lessons, written explanation, downloadable resources, and much more. So you can find that in the video link description. Like I say, hopefully this has been helpful. Thank you very much for watching. But for now, I'm going to see you in another video. Peace out.